Hi everyone, welcome to week 11 for junior cycle higher level. Today the lesson is going to be split into two parts. So the first part is going to be quadratic functions and the second part is going to be exponential functions. So we're going to deal with quadratic functions first. Now when we're dealing with quadratic functions, you will remember that it takes the general form, so I'm going to write it out. So f of x is equal to ax squared plus bx plus c. So you'll know if you see a squared term that it's a quadratic function. Now functions can be showed in three different ways. That's the first way, or shown should I say. The second way is two dots x going to with an arrow and we ax squared plus bx plus c. Or the third way would be that y is equal to ax squared plus bx plus c. So it's really important to remember that either of those three ways can be used as a function. So it's important to be able to recognize all of them. So we're going to do an example of a quadratic function. So I'm going to write down a function. So the f of x is equal to x squared minus 5x plus 4. Okay, so that's the function, and we want to plot it in the domain -1 is less than or equal to x is less than or equal to 5. So we know that our x values are going to go between -1 and 5, and we plot them into this function here. So usually what I do is a table, so that's kind of the best way to make sure that you don't make any mistakes. So we have a table for x, our function. So x squared minus 5x plus 4, and then our y values. So our x values are -1, 0, 1, 2, 3, 4, and 5, and we're putting them into the function. So x squared, so that's going to be -1 squared, minus 5 by -1 plus 4. And when you put that into the calculator, you'll get a result of 10. So your first point there is going to be -1, 10. Your next one is going to be 0 squared minus 5 by 0 plus 4. And that will give you a result of 4. So your point there is 0, 4. The next point is 1 squared minus 5 by 1 plus 4. And that will give you a result of 0. So the point there is 1, 0. The next point is 2 squared minus 5 by 2 plus 4. And when you put that into the calculator, you'll get -2. So your point is 2 minus 2. The next point is 3 squared minus 5 by 3 plus 4. And when you put that into the calculator, you get -2 again. So your point is 3 minus 2. And then 4 squared minus 5 by 4 plus 4. And you get a result of 0 on the calculator. And then finally 5 squared minus 5 by 5 plus 4. And when you put that into the calculator, you get a result of 4. And I forgot to put in the point there for this one. So it's going to be 4, 0 and 5, 4. So now you have a set of points. So what you're going to do is plot them on a diagram or on graph paper. So I'm going to paste in what your graph should look like once you've all of these points figured out from the function. Okay, so you should have something like this. It should be in a U shape, and you can actually tell that it's going to be a U because if the x squared term is positive, which it is there, then that means it's going to take a U shape. So you always look to see what sign is in front of the x squared coefficient. So there's no sign, so we assume it's positive. So if it's positive, it takes a U shape. Now, if we look at the first point, -1, 10. So -1 is going to be roughly here and 10 is there. That's the first point. Second point is 0, 4. So 0 on the x-axis and 4 on the y-axis is there. The next point is 1, 0. So 1 on the x-axis, which is there, and 0 on the y-axis. Then we have the point 2, -2. So 2 on the x-axis and drop to -2. Then we have 3, -2, so we go to the point 3, which is in between 2 and 4, which would be roughly here, and -2 drop. Then we have the point 4 and 0, so 4 and 0 is there. And finally the point 5, 4, so 5 on the x-axis will be roughly here and up to 4. So So there you can see it's in the shape of a U, and we call that a parabola. So I'm just going to write that at the top. So the shape of the curve is a parabola. Okay, so we're still on quadratic functions. Now, looking at the function itself, we can tell what shape it's going to be. So we're going to draw another one. We're going to look at another one. So if we said the function f of x is 10 minus x minus 2x squared. So if you were asked to, first of all, draw a graph of the function, and then you were asked to use your graph to estimate the maximum value for the f of x. And then the last part of that question, use your graph to estimate the values for which the f of x is 6. Okay, so first of all, let's look at the x squared term, which is here, and the coefficient in front of it, which is 2. Well, it's actually minus 2. And that brings me to my next point. Look at the sign that's in front of the x squared term. It's minus. If it's a minus, that means it's in an n shape. I always think n for negative, so I'm just going to write that here. So n for negative, and it's in the shape of an n. So you always look for the x squared term and see what sign is in front of it. If it's a minus, it's negative, and if it's a positive, it's going to be in a U shape like I showed you in the previous slide. So we are asked to draw a graph of this function, and sorry, I forgot to put in the domain actually. So the domain is minus 3 is less than or equal to x is less than or equal to 3. So you have to go from minus 3 up to 3. So let's draw our table here. So our x values, our f of x, which is our rule, which is 10 minus x minus 2x squared, and then our corresponding y values. So our x values go from 3 all the way up, sorry, minus 3 all the way up to 3. So minus 3, minus 2, minus 1, 0, 1, 2, 3. So we plug them into the function. So the f of x is equal to 10 minus minus 3, be careful there, minus 2 by minus 3 squared. So when you plug that into the calculator, you get a value of minus 5. So your first point there is minus 3 minus 5. The next point, so the f of x is equal to 10 minus minus 2, minus 2 by minus 2 squared. And when you plug that into the calculator, you will get 4. So that point is going to be minus 2, 4. The next one, f of x is equal to 10 minus minus 1, minus 2 by minus 1 squared. And when you put that into the calculator, you get 9. So your point there is minus 1, 9. Then you put 0 in, so the f of x is equal to 10 minus 0 minus 2 by 0 squared. And when you put that into the calculator, you get 10. So that point is 0, 10. The next point is 10 minus 1 minus 2 by 1 squared. Put that into the calculator, you get a value of 7. Your point then is going to be 1, 7. Then we have the f of x is equal to 10 minus 2 by 2 squared, and you get a value of 0, so that point is going to be 2, 0. And finally, the f of x is equal to 10 minus 3 minus 2 by 3 squared. And again, when you put it into the calculator, you get a result of minus 11. So your point is going to be 3 minus 11. So I'm just going to paste up what your graph should look like. Okay, so as you can see, this graph is in the shape of an n, which is what we wanted because the coefficient of x squared was negative. So that's the first part answered, to draw the graph of the function. That's what you should get something like this. Now, use your graph to estimate the maximum value for the f of x. The maximum value is the highest point on the graph, which is here. And if you look at the green dashed line there, the highest point is roughly about 10.25, but usually it's a range that's given. So between, we say 10 and 10.25, you would get your marks there. So that's the answer to part B. So I'm just going to write that down. So for part B, the maximum value for the f of x is 10.25. So the max value. Now for part C, you are asked, use your graph to estimate the values for which the f of x equals 6. Now, the f of x equals 6. So another way of writing this is y is equal to 6. So remember the three ways that I showed before that we can use to write a function. So instead of writing the f of x is 6, we write y is 6. We'll go to the y-axis, find where 6 is on the y-axis, which is here, and we're going to come across and see where it hits your curve. Okay, so we go left and come down, it hits it at roughly, I would read that as maybe minus 1.8 there. So I'm going to write that down as one of the values. So x is equal to minus 1.8, and then the other value, if we come across and down, I would read that as roughly 1.1, 1.2. We'll say 1.2. So x equals 1.2. So that's a quadratic function question when the coefficient of x is negative. So as you can see, it's an N shape, and you should be able to answer the questions that go with it as well. So the next thing we're looking at under quadratic functions is axis of symmetry. So many shapes with equal angles or sides will have an axis or maybe several axes of symmetry. So you might find it helpful to think about folding the shape over an axis of symmetry. So for example, an isosceles triangle which has two equal sides and two equal angles, you could fold that directly on top of the other, and it has one axis of symmetry here. The next thing we look at is a equilateral triangle, which means that all sides and all angles are the same. So here there are three axes of symmetry. Each one passes through a vertex perpendicular to the opposite side. So you could fold it over that side on top of that side. You could fold it that side on top of that side, or you could fold that side on top of that side, and it would come out as an even shape. So we look at the next one. A square has four axes of symmetry, one horizontal, one vertical, and two diagonal. So you could fold that diagonal down on top of that diagonal down on top of that. You could fold it this side over on top of this side, or this side over on top of this side. So I think the best way to kind of visualize this is folding it over. And then more complicated shapes have more axes of symmetry. So the hourglass here, it has two. So you could fold this side here over on top of this side, or you could fold it from bottom to top either. So it's important to kind of recognize how many axes of symmetry a certain shape will have. Okay, so we're going on to the second part of the lesson now, which is exponential functions. So with an exponential function, an example of one would be the f of x is equal to 2 to the power of x. So when it's exponential, it's to the power of something. Okay, so that's how you know it's exponential. Now we'll say in the domain, so we're going to plot this in the domain, minus 3 is less than or equal to x is less than or equal to 3. So this function has a characteristic shape when plotted as well. So usually an exponential function will look something like this. Now this is just a kind of a sketch, but it'll look something like that. But you'll see when we start to plot. So let's do out our table as normal. So our x values, the f of x is equal to 2 to the power of x, and then our y values. So we have to go from minus 3 up to 3. So minus 3, minus 2, minus 1, 0, 1, 2, and 3. We're going to put it into the function. So the first one there is going to be 2 to the power of minus 3. When you plug that into the calculator, it'll give you 1/8. So 1 over 8. Next thing is 2 to the power of minus 2. and that will give you 1/4. The next one is 2 to the power of minus 1, and that's going to be 1/2. Now, sorry, I need to put in these points. The first point there is minus 3 and an eighth. The second point is minus 2 and 1/4. And the next one is minus 1 and 1/2. 0 is 2 to the power of 0. Now, anything to the power of 0 always gives you 1, so you need to remember that as a rule. So the point there is 0 and 1. Next point is 1, so 2 to the power of 1 is just going to be 2. So that point is 1, 2. The next point is 2 to the power of 2, which is 4. So that point is 2, 4. And then the final point, 3. So it's 2 to the power of 3, which is 8. So your point there is going to be 3 and 8. So we now need to plot these points. So I'm going to paste in what the graph should look like. So you should get something like what you see there. So let's just double check the points. So the first point is minus 3 and an eighth. So minus 3 is here and an eighth would just be roughly there. So that's the first point. Next point is minus 2 and 1/4. So minus 2 is here. 1/4, so between 0 and 1, 1/4 would roughly be there. So minus 2 and 1/4 is that point. The next point is minus 1 and 1/2. So minus 1 on the x-axis is here. And 1/2 between 0 and 1 is roughly there. It's half. Next point is 0, 1. So 0 on the x-axis and 1 on the y-axis. Then we have the point 1, 2. So go to 1 on the x-axis and 2 on the y-axis. Then we have the point 2, 4. So the point 2 on the x-axis and 4 on the y-axis. The point 3 and 8, so 3 on the x-axis and 8 on the y-axis. And then what you do is you get your pencil and you join up all of the points as best you can, and you'll get a shape like you see on the screen there. So it's really important to remember what your different functions will look like. So we've already looked at linear. So I'm just going to just do a quick sketch here. So linear is going to look something like that. Quadratic, where the coefficient of x is positive, is going to be u. Quadratic, where the coefficient of x is negative, is an n. And then finally, what we're after doing there, an exponential function, will look something like that. So you should know by looking at the function, like for example here, 2 to the power of x, that you're going to get something like that. So just be very careful as to which function it is you're being asked for, and you can nearly predict, looking at the function, what your graph should look like. I'm going to pull some exam questions now, and we're going to go through a couple of different questions that could come up on the papers. Okay, so I pulled this question and it's on graphing functions, and it's from 2017, and it's paper 1, question 13. So we're going to get practice here now at drawing the 3 different types of functions. So it says to draw each of the following 3 functions in the domain minus 2 goes to 2. So what we do is draw out our table. So our x values, so they go from minus 2, minus 1, 0, 1 and 2. And our rule is the f of x, in other words y, is equal to x minus 1, and our y values then. So the f of x is x minus 1, so it's going to be minus 2 minus 1, which is minus 3, which means the point is minus 2 minus 3. Next one is going to be x minus 1, so minus 1 minus 1, which brings us to minus 2, so the point is minus 1 minus 2. Next point is 0 minus 1, which gives a value of minus 1, so the point is 0 minus 1. Then we have 1 minus 1, which is 0, which gives us a point of 1, 0. And then finally, we have a value of 2, so 2 minus 1 gives us 1, and the point then is 2 and 1. So we're going to plot those 5 points. So the point minus 2, minus 3. So minus 2 on the x-axis here and drop to minus 3, so your first point is going to be there. And then the next point is minus 1, minus 2. So minus 1 on the x-axis and minus 2 on the y-axis is here. So we're going to draw that point. Now, just before I continue, look at this. This is linear. You have x and a constant, so it's going to be linear. So we know we're going to be forming a line. The next point is 0, minus 1. So 0 on the x-axis, minus 1 on the y-axis is there. So I'm just going to colour in my point there. Then we have the point 1, 0, which is going to be here. And then we have the point 2, 1, which is here. Now your best thing here is to use a ruler to draw or to connect your points and try and get the best fit line you can. So I'm just going to join up all my points there, and that gives me my function. So we'll have a look at the next one now. So our x values, they're the same domain. So minus 2, minus 1, 0, 1, 2. And our rule this time is 2 minus x squared. Now because there's an x squared, we know it's a quadratic. Look at the sign that's in front of the x squared, which is a minus, which means it's going to be an n shape. And then our y values. So we plug it in. So it's going to be 2 minus 2 squared. Now you square a negative number, it always becomes positive. So that there would become 2 minus 4. So 2 minus 4 is minus 2. So the point is minus 2, minus 2. Next point is 2 minus 1 squared. So minus 1 squared is plus 1. So 2 take away 1 is 1. So the point there is minus 1, 1. Next point is 2 minus 0 squared, which is going to be 2. So the point there is 0, 2. And the next point is 2 minus 1 squared. So that's 2 take away 1, which is 1. That gives us the point 1, 1. And then finally, it's going to be 2 minus 2 squared. So that's 2 take away 4, which is minus 2. So that's the point 2, minus 2. So hopefully we're going to get an N shape. So we'll put in the first point, minus 2, minus 2. So minus 2 on the x-axis, minus 2 on the y-axis is there. So we'll draw on that first point. The next point is minus 1, 1. So minus 1 is there and up to 1 is that point there. So we'll mark that in. So minus 1 and 1. The next point is 0, 2, which is here. Next point is 1, 1, which is here. You can start to see an N shape forming. And the last point is 2, minus 2, which is here. So then what you do is you draw the best curve you can do. It's going to be harder now because I'm doing it on a tablet here. But yeah, something like that. And you get your N shape. So we'll go to the last function. So we can see that this is an exponential function. So we remember from the previous slide what it's going to look like. So we'll draw out our tables. We've got our x values. Our function is 2 to the power of x, and then our y values. So again, same domain. So minus 2, minus 1, 0, 1, and 2. So 2 to the power of x. So 2 to the power of minus 2. So 2 to the power of minus 2. That's 0.25. So the point there is minus 2 and 0.25, which is a quarter. Next one is 2 to the power of minus 1, and 2 to the power of minus 1 is 0.5. So 0.5. So your point there is minus 1 and 0.5. Next point is 2 to the power of 0. Anything to the power of 0 is 1. So the point there is 0, 1. The next point then is 2 to the power of 1. So that's going to be 2. So the point there is 1, 2. And then finally 2 to the power of 2, which is 4. So the point there is 2 and 4. So we're just going to plot these points now. So we're going to plot the points now. So minus 2 and 0.25. So minus 2 on the x-axis and 0.25 on the y-axis is going to be roughly there. So I'm just going to mark that in. It's going to be roughly about here. The next point is minus 1 and 0.5. So minus 1 on the x-axis and 0.5 on the y-axis is going to be roughly here. I'm going to mark that in. Next point is 0, 1, which is going to be there. Next point is 1, 2, which is here. And the final point is 2, 4, which is up here. And you can see it's starting to form the shape that it should when it's an exponential. So there are the three graphs drawn. It's really important that you're able to do that and you're able to recognize whether it's a quadratic, a linear, or an exponential function. Just to reiterate again, when we have a linear function, it takes the form the f of x is equal to ax plus b. So for example, 2x plus 1. Okay, and it looks like this, where you have a line. You could have a quadratic, where it takes, there's two possibilities. So you have ax squared plus bx plus c, or minus ax squared plus bx plus c. In which case, so this 1a will look like a u because a is negative, or the x squared coefficient is negative. Here it'll look like an n for negative because again the coefficient is negative. And then the last one is exponential. And that's where you have a graph that looks like that. And that's where you have maybe a to the power of x. So it's very important that you remember those three, or those four should I say. So we're going to do one more question now based on what we're after going through there. Okay, so there's one more question here that we're going to go through. This is 2017, paper 1, and it's question 15. So the question is, there are three curves A, B and C, and they're all shown in coordinate diagrams below. Two of the curves show a function of x. Put a tick in the correct box to show which curve does not show a function of x and give a reason for your answer. So there's a trick to solving this question, and we use a thing called the vertical line test. So an idea here would be to get your ruler and use a different colour. So I'm going to draw two vertical lines on the graph A. So I'm going to draw one here and I'm going to draw another one here. I'm going to do the same to the second graph. I'm going to draw a vertical line here and I'm going to draw a vertical line also here and here again. And I'm going to do the same thing then to part C, or graph C should I say. I'm going to draw one vertical line there. So the reason I have done that is each x value should only have one corresponding y value, and the way you test that is using these vertical lines. So you can see this vertical line only hits the function once there. If I drew a vertical line here, it only cuts the function or hits the function once there. Same with this one, it only hits the function once here. If I drew another one here, it only hits the function once, which is here, and again it only hits the function once, which is there. Now if we look at C, I drew a vertical line here and it cut the function there, there and also there, and because of that it's not a function. The vertical line cuts the graph three times. It cuts it here, it cuts it here, and it cuts it here. So the answer to that question is C is not a function of x, and the reason is because we can draw a vertical line. So we can draw a vertical line through C that cuts the graph more than once. And for that reason, it is not a function. So that's two of the higher level questions from functions. I am going to attach some extra links to some video tutorials and extra questions as well, so I'd recommend that you follow them, and I will speak to you next week. Hi everyone.